Hi students, in this video we will be solving an important 5 marks question that can appear in part D of Karnataka PU board exam, and this is from the chapter Matrices, and this is a second PU syllabus. From the Matrices chapter, a 5 marks question appears in part D main of the second PU question paper. So I'll be solving one of them. Now you can see it is worked example 16 that I am solving now. Why am I solving a worked example? As I have told you in many of my videos that you should always solve all the worked examples from the textbook. Not only the exercise, worked examples also have to be solved because this particular worked example has appeared some 2 to 3 times in the exam. So in any chapter for that matter, do not ignore the worked examples. So this is one of the important worked examples which I'll be solving today. Okay. Now to solve this sum, you need to know matrix multiplication, which is very, very important. In brief, I'll explain matrix multiplication in this video. So let us check the question now. If A is a matrix, 3 cross 3 matrix, that means it has 3 rows and 3 columns, and B is a matrix which is 3 cross 2 matrix, that is 3 rows and 2 columns, and C is another matrix which is 2 cross 4 matrix, that is 2 rows and 4 columns. Okay, now we have to find A into BC and AB into C. After that, we have to show that AB into C is equal to A into BC. So, if you just check what are we doing here, we will be proving the associative property for these three matrices. And what is the mathematical operation? It is matrix multiplication. So, matrix multiplication holds good for associativity. Is that clear? Yes. But you very well know that it is not commutative. In no circumstance we can interchange AB with BA. Here BC with CB. So it has to be in the same order only, since matrix multiplication is not commutative. Is this clear? Okay. Now first let us find AB. I will find AB first. So I am considering matrix A and matrix B. So matrix A is of the order 3 cross 3 and matrix B is of the order 3 cross 2. Now you already know that any two matrices cannot be multiplied. There is a condition for two matrices which can be multiplied or which are compatible for multiplication. And what is that condition? That is, if this is row and this is column, if I am finding AB, then I am considering the order of matrix A first, then order of matrix B next. In such case, number of columns of the first matrix should be same as number of rows of the second matrix. Is this clear? If this condition holds good, only then matrix multiplication is defined. That is what I have written here. Number of columns of first matrix should be equal to number of rows of the second matrix. Only then two considered matrices are compatible for multiplication. So in this case, it is same and these two matrices are compatible for multiplication and multiplication can be done. So when we multiply two matrices, what we get is also a matrix. That is, the result is also a matrix. And what will that matrix be of the order? It will be of the order this cross this. That is, number of rows of the first matrix and number of columns of the second matrix. That will be the order. In this case, the resulting matrix will be of the order 3 cross 2. Hope I am clear till this stage. Now we shall consider the two matrices to be multiplied. And in general, whenever a question appears for 5 marks, definitely such matrices will be compatible for multiplication. But you need to know this condition. When you will be solving MCQs, you have to check this condition. Otherwise, for 5 marks, definitely they will give you matrices whose multiplication will be possible or will compatible for multiplication. Is that clear? Now, I have written A into B. So, matrix A and this is matrix B. So, in brief, let me explain how do we multiply any two matrices. First, we consider the first row of the first matrix. First row of the first matrix. Then, we will consider the first column of the second matrix and multiply the corresponding elements. Then, sum it up. We will be multiplying first element from the first row to the first element of the first column of the second matrix. Is this clear? Then add that to second element of the first row to second element of the first column. Then third element of the first row to third element of the first column. We will multiply each one of them, then add them up. That actually gives us the very first element of the first row. Or we can also say first column. So after we have done with the first column, we will consider the first row itself. Then we will multiply the corresponding terms with the second column and add them up. Clear? Corresponding terms is what we will be multiplying with and adding them gives the next term. Then after, suppose if you were to have another column here, then if it were to be 3 cross 3, then we would again multiply the first row with the third column. Is this clear? Now, once we are done with first row of the first matrix with all the 3 columns of the second matrix, then we will go to second row. When we consider second row, we will multiply the elements with the first column elements of the second matrix. That is, corresponding elements will be multiplied second row, first column. Once we are done with that, then we will consider second row, second column. Is this clear? Then we get the next term. When I say multiply the row into column, it is not that we will be multiplying the row or column. We will be multiplying the corresponding elements of that particular row with column. Do you understand? Now, once we are done with all the columns with the second row, we will go to the next row of the first matrix. We will go to third row, consider third row, multiply the corresponding elements with the first column. That will give us this element. Then third row with the next column, that is second column in this case, gives us this term. Is this clear? Now we'll consider first row, first column. 1 into 1 is 1 plus 1 into 0, that is plus 0. Then minus 1 into minus 1 gives us plus 1. So we multiplied the corresponding terms. First term, then second term, then third term. That is row multiplied by the column elements. Then we are done with the first term. Then first row, second column. Again we'll multiply with the corresponding terms. 1 into 3 gives us 3. 1 into 2 gives us 2. Minus 1 into 4 gives us minus 4. So it is 3 plus 2 minus 4. Now we are done with the first row. Now let us go to second row. Now let us consider second row. That is second row with the first column, which gives us 2 into 1, 2 plus 0 into 0, 0. Then 3 into minus 1 gives us minus 3. So now second row and second column is what we are going to multiply. That gives us 2 into 3 is 6 plus 2 into 0 is 0 plus 3 into 4 gives us 12. That is 6 plus 0 plus 12. Now we are done with second row also. We can consider third row now. Third row and first column. So 3 into 1 gives us 3. Minus 1 into 0 is 0. 2 into minus 1 is minus 2. So this will be 3 plus 0 minus 2. Now third row, second column. That gives us 3 into 3, 9. Minus 1 into 2, minus 2. Then 4 into 2, it is 8. So 9 minus 2 plus 8. Now we'll simplify this. 1 plus 1 gives us 2. 5 minus 4 gives us 1. 2 minus 3 gives us minus 1. Then 6 plus 12 gives us 18. Then 3 minus 2 gives us 1. Then 7 plus 8 gives us 15. So this is matrix AB. Is this clear? We considered two matrices. We multiplied them. The result is also a matrix, which is matrix AB. Now, what should our matrix be of order? It is 3 cross 2, right? Yes, we have got the matrix of order 3 cross 2. Now, we will multiply this matrix AB with C. So, now we will be considering matrix AB, which we have just found, and then matrix C. So, I have written both the matrices. Now, matrix AB is of order 3 cross 2 and C is of the order 2 cross 4. Now, you can see that number of columns of the first matrix is same as number of rows of the second matrix. So, These two matrices are compatible for multiplication and the resulting matrix will be of the order 3 cross 4. So AB into C. I'm directly multiplying from here. So it is first row into first column, which gives us the first element. Then first row into second column gives us this element. Then first row into third column gives us this element. First row into fourth column gives us this element. Again, once we are done with the first row, we can consider the second row. Second row, again multiply with all the 4 different columns. We get 4 elements in the second row. We will consider third row and we will again multiply with first, second, third and fourth columns and we get these 4 elements. Is this clear? We shall do it now. Now to start with, we are considering first row, first column. That is 2 into 1 plus 2 into 1. We are multiplying the corresponding elements. That is first, and this is first element, this is second element. This is first element, this is second element. Correct? Yes. We have multiplied the corresponding elements. Now, first row, second column. That gives us 2 into 2, 4 plus 1 into 0, 0. Then first row, third column, which gives us 2 into 3 as 6. Then 1 into minus 2 as minus 2. First row into fourth column. That gives us 2 into minus 4, which is minus 8. Then 1 into 1 gives us 1. So it is minus 8 plus 1. Now we are done with first row. We'll consider second row now. Second row to be multiplied with all 4 columns. Correct? So second row, first column, which gives us minus 1 into 1, which is minus 1. 18 into 2 gives us 36. So this will be minus 1 plus 36. Now second row, second column gives us minus 1 into 2, which is minus 2. 18 into 0 is this 0. So minus 2 plus 0. Now second row, third column, which is minus 1 into 3, minus 3. Then 18 into 2, minus 36. So this term is minus 3 minus 36. Again, second row, fourth column is what we are going to consider. Minus 1 into minus 4 gives us plus 4. Then 18 into 1 gives us 18. So it is 4 plus 18. So when we multiply the corresponding terms, we will sum up all of them, right? That is what we have done here. Now we are done with first 2 rows. It is going to be third row now. Third row with first column, which is 1 into 1 is 1. 15 into 2 is 30. So it is 1 plus 30. Then third row, second column, which is 1 into 2 is 2 plus 15 into 0, 0. So third row with third column. So it is 3 into 1, which is 3. 15 into minus 2 is minus 30. So it is 3 minus 30. Then again, third row, fourth column gives us 1 into minus 4, which is minus 4 plus 15 into 1 is 15. So it is minus 4 plus 15. Now we shall simplify this. This is 2 plus 2, 4. This is 4 again. This is 6 minus 2, 4. Minus 8 plus 1 is minus 7. Then minus 1 plus 36 is 35. Then it is minus 2 here. Then it is minus 39 in this case. This is 22. That is 4 plus 18, 22. So it is 22 here. Then this is 31, which is 31 here. This is 2 here. Then this is minus 27. 3 minus 30. So it is minus 27 here. Minus 4 plus 15, which will be 11 here. So this is the resulting matrix. Now we can see that AB into C is a matrix of order 3 cross 4. That is what we should get, right? 3 cross 4. Yes, 3 cross 4. So we have got a matrix which is of the order 3 cross 4. Now we have to find BC, then multiply it with matrix A. That is A into BC. We should not change the order. I am considering matrix B and matrix C. We'll check the orders now. Order of matrix B is 3 cross 2 and order of matrix C is 2 cross 4. Now you can see these two matrices are compatible for multiplication and the resulting matrix will be of the order 3 cross 4. Clear? Yes. Now B and C. So we are multiplying first row with all the 4 columns, of course with the corresponding elements. Then we'll consider second row, multiply with all the 4 columns. Then third row, multiply with all the 4 columns. So to start with, I'm considering first row, first column. So this is the first element, this is the first element, second element and second element, right? Yes. So it is 1 into 1, which is 1. Then 3 into 2, which is 6. So summing up these two terms gives us 1 plus 6. Now first row with second column, which gives us 1 into 2, that is 2. Then 3 into 0, 0. So it is 2 plus 0. Now first row, third column, which is 1 into 3. Then 3 into minus 2, which gives us minus 6. So it is 3 minus 6. Now it is first row, fourth column. 1 into minus 4 is minus 4, plus 1 into 3 is plus 3. Now we are done with first row. We can consider second row now. Second row with all 4 columns. So second row multiplied by first column. That gives us 0 into 1 is 0. Then 2 into 2 plus 4. So it is 0 plus 4. Now we can see that when we are multiplying this term, the first term of the second row with the first terms of all the columns, definitely it will be 0, right? So you can easily write 0 to all the 4 terms here. Clear? Okay. Now second row, first column. 0 into 1 is 0. 2 into 2, 4. Then second row, second column gives 0 into 2 gives 0. 2 into 0 is also 0. Then second row, third column. So 0 into 3 is 3. Then 2 into minus 2 is minus 4. Then second row, fourth column. So 0 into minus 4 is 0. Then 2 into 1 is 2. So it is 0 plus 2. Okay. Now we are done with first 2 rows. We'll consider third row and we'll multiply with the first column. That gives us minus 1 into 1 is minus 1. 4 into 2 is 8. So it is minus 1 plus 8. Now third row, second column. Minus 1 into 2 plus 4 into 0. That gives us minus 2 plus 0. Then we'll multiply third row with third column. So minus 1 into 3 is minus 3. Then 4 into minus 2 is minus 8. So it is minus 3 minus 8. Now third row with fourth column. Minus 1 into minus 4 is plus 4. Then 4 into 1 is 4. 4 plus 4. So on simplification, what we get is 7 here. 2. This is minus 3. And this is minus 1 here. Then again this is 4. This term is 0. Then it is minus 4. Then it is plus 2. Now the third row. This is 7. Yes, 7. So this is minus 2, minus 2. This is minus 11 here. And this is plus 8. Now you can see that we have got a matrix of the order 3 cross 4. Yes. So we have found BC and the order of the matrix BC is 3 cross 4. Now what is it that we have to do? A into BC is what we have to find. So A will be the first term, then BC, matrix BC will be the second term. That is how we have to multiply. We cannot change the order as matrix multiplication is not commutative. I am repeating it again and again so that it gets registered in your mind. Matrix A is of order 3 cross 3 and BC is of order 3 cross 4. Now you can see matrix multiplication is compatible and the resulting matrix will be of order 3 cross 4. Now we'll consider first row and multiply with the corresponding elements of all the 4 columns. So first row with first column. That gives us 1 into 7 is 7. 1 into 4 is 4. Minus 1 into 7 is minus 7. That gives us 7 plus 4 minus 7. Then we'll be considering the first row with the second column. 1 into 2 is 2. Then 1 into 0 is 0. minus 1 into minus 2 is plus 2. So it is 2 plus 0 plus 2. Then first row with third column. Then it is 1 into minus 3, minus 3. 1 into minus 4 is minus 4. Then minus 1 into minus 11 will be plus 11. This gives us minus 3 minus 4 plus 11. Now first row to be multiplied with the terms of the fourth column. That is 1 into minus 1 is minus 1. 1 into 2 is plus 2. Then minus 1 into 8 is minus 8. That gives us minus 1 plus 2 minus 8. Now we are done with first row. Again, next we will be considering second row and multiplying with the corresponding terms of all the four columns. Second row and first column is what we are going to consider now. 2 into 7 is 14. Then 0 into 4 is 0. 3 into 7 is 21. That gives us 14 plus 0 plus 21. Now second row with second column. That gives us 2 into 2 is 4. 0 into 0 is 0. 3 into minus 2 is minus 6. So it is 4 plus 0 minus 6. Now second row with third column. So it is 2 into minus 3 is minus 6. 0 into minus 4 is 0. Then 3 into minus 11 is minus 33. Now we'll be considering second row with the fourth column. 2 into minus 1 is minus 2. Then 0 into 2 is 0. Then 3 into 8 is 24. So it is minus 2 plus 0 plus 24. If you can see, middle term of the second row is 0. It gets multiplied with the middle terms of all the four columns. Middle term of this, middle term of this, middle term of this, middle term of this. Correct? So that will become 0. You can see the middle term has become 0 because of this one 0 here. You can directly write that. That you can do by practice. Now we are done with first two rows. We will be considering the third row of the first matrix. Third row and first column, that is 3 into 7, which will be 21. Minus 1 into 4 is minus 4. Then 2 into 7 is 14, which gives us 21 minus 4 plus 14. Then third row with second column. So 3 into 2 is 6. Then minus 1 into 0 is 0. Then 2 into minus 2 is minus 4, which gives us 6 plus 0 minus 4. Now third row with third column. That gives us 3 into minus 3 as minus 9. Minus 1 into minus 4 as plus 4. Then 2 into minus 11 as minus 22. So what we get is minus 9 plus 4 minus 22. Now finally third row with fourth column. So 3 into minus 1 is minus 3. Minus 1 into 2 is minus 2. Then 2 into 8 is 16. That is minus 3 minus 2 plus 16. Now one simplification. This will be 4. Then this will again be 4. And this will be minus 7 plus 11, which is again 4. Then this is 1 minus 8. So minus 7. Now this will be 35. And this will be minus 2. And this is minus 6 minus 33. So minus 39. And this will be 22. Then again this will be 31. This will be 2. This will be minus 27. And this will be 11. So if you can recollect and rewrite the matrix AB into C that we have already found. Compare the corresponding elements and we can see that they both are equal matrices. They both are equal with the same order, that is 3 cross 4. Therefore, any two matrices to be equal, the order should be same and the corresponding elements should also be same, right? If you can compare and see, A into BC is same as AB into C. So we have just proved that matrix multiplication holds good for associative property. Is this clear? Yes. If you still have any doubt, please do mention it in the comment section.